Cool. Hello, everyone. First of all, thanks very much for being here, almost full room. Today, I want to talk to you about WebAssembly, and especially WebAssembly when it comes to running outside the browser. The point of this talk is that, maybe you heard about WebAssembly, maybe you used it in the front end, and now you are probably hearing, okay, WebAssembly, is this next big thing? Can I run it on the server side? Maybe you have some ideas, but you don't know exactly what's happening. And rightly so, because it's a very confusing landscape and it's a very fast-changing landscape. So at the end of this talk, hopefully you will get a good overview of what WebAssembly is and what its state is on the server side, and then where we are going. And hopefully this will provide you all the information that you need, so that if someone asks you, what is a WebAssembly? Can I run it on the server side? Hopefully you will be able to answer that. That's my goal with this talk. The slides are on speaker deck already. So if you want to grab the slides afterwards, feel free. The demos I'm going to show, they're already on GitHub, so you'll be able to get those as well. And I'm going to share these links at the end of the presentation as well, so feel free to take a picture at the end as well. All right. What is WebAssembly, and why should we even care about that, right? We need to ask this question in tech because there's so many things to learn, and there's not enough time. So we need to set the stage first. What is WebAssembly? This is the official definition from their website. It's a binary instruction format for a stack-based virtual machine. Okay, it's a virtual machine. And it's also a portable compilation target for programming languages. So you compile languages to a module, I assume, and then you run them in a virtual machine. This sounds familiar, right? Like if you're thinking Java, JVM, similar kind of idea. So what is it? How is it different? Well, we'll see. Now, the original use case of WebAssembly was to augment JavaScript. For better or worse, we're stuck with JavaScript in the front end, and sometimes you cannot run JavaScript. Maybe you have a native code for a game written in Unity, C#, and you can just rewrite the whole thing in JavaScript, or maybe you have some 3D graphics kind of code. So the idea with WebAssembly is that you take the code, compile that into a WebAssembly module, and run within the browser in a portable, secure way. And this is supported by all major browsers, and it's been around for a while, right? And this is exactly why I ignored WebAssembly for a long time, because I'm not a front-end developer. I'm mostly back-end cloud developer. So this didn't look like it's something I'm interested in. And even if I'm working on front-end, I'm usually working on something simple. I don't need to run 3D graphics or games or anything like that, right? So I kind of kept ignoring it until I started seeing tweets like this. So the first tweet was back in 2019 from this person, Lynn Clark. And she was talking about this new thing called WASI that we'll talk about that enables WebAssembly to run outside the browser. Okay. Well, there are many projects, so this is one of them. What's the big deal? But then there was a reply to that from Solomon Hykes, who's one of the, or maybe the co-founder of Docker. And he's basically saying that if Wasm and WASI existed back in 2008, maybe we didn't need to create containers or Docker, right? So when I saw that, I said, okay, well, maybe this is something that's relevant for me too, because containers have been the de facto standard of packaging and running applications, especially in the cloud, in the last 5 years or so. So if this is something that's relevant for that, maybe it's relevant for me. And then there was a survey back in 2022, so last year, from CNCF. And one of the key findings was that containers are the new normal and WebAssembly is the future. Okay, so now I'm paying attention, because if it's going to be the future way of running things, then we do need to pay attention as backend or cloud developers. So that's when I started looking into WebAssembly. And the idea of WebAssembly outside the browser started with a project called WASI. And we'll talk more about this project in a little bit. And the idea here is that instead of running your applications as virtual machines or containers, you can run them faster, smaller, more secure, more portable way using WebAssembly modules. Well, it sounds nice, right? Why not? Like if I can run everything faster, smaller, more secure, more portable way. But what are these actually true? I mean, how is it faster? Well, faster because Wasm applications typically start faster than containers with no cold start. At least this is the claim. Smaller, because if you take, for example, let's say a Hello World Rust application and compile to a Wasm module, this is typically much smaller than taking the same application and putting it in a container and using that container as kind of the unit of deployment. More secure, because containers, they have this allow by default security model where things are allowed and you need to kind of lock them down. And there's a lot of work happening in container space to make them more secure. But I always get nervous about them because, when I have a container, I'm never sure whether it's secure enough, and I always kind of delegate that to someone else. Whereas in WebAssembly, it's the deny by default sandbox, meaning everything is kind of denied, and you need to explicitly export your functions and import your functions to be able to use them. So that kind of makes it a little bit more secure than containers. And more portable, sometimes we forget that if you build a container for, say, Linux AMD64 architecture, you cannot run it on Linux ARM architecture, right? And forget about running it on Windows, for example, right? Whereas if you take a WebAssembly module compiled for Wasm WASI, you can run it anywhere you have a Wasm runtime. So in that sense, it's more portable. I didn't put any numbers here in terms of how much faster it is and how much smaller it is. Because as soon as I put numbers, then I have to justify them. And then when you justify them, then people say, okay, well, this is not really a real-world kind of use case. If you do this, maybe it's not the same, blah, blah, blah. Let's agree that at least these are the claims of WebAssembly. And from my simple test, I've seen that it's faster and smaller. But we'll see if they will deliver on these promises. So this makes me think that, okay, back in the day, we used to run software on hardware. Then we started running them on virtual machines, so we can kind of abstract the hardware. Then containers came along, and we started running them in containers, more isolated. Then nowadays, we are just running them on containers. For example, on Google Cloud, there's a service called Cloud Run, where you literally just pass in your container, and you just run that container. You don't even need to think about what's underneath the container. So we are thinking just in terms of containers. So maybe WebAssembly is the next iteration of this. Maybe at some point we'll be thinking, okay, this is my code. I compile to WebAssembly module, and that's it. Like, I don't care about the rest of the stuff. And this is a question mark. I don't know. We'll see. All right, and then you might be wondering at this point, okay, well, this sounds good, but what kind of use cases are good for WebAssembly, and what kind of things I can do with it? There's this really good blog post from Fermion, which is a startup that's focused on WebAssembly that I'll talk more about later. And you can read in more details, but they basically laid out these 4 use cases that I agree with. The first use case is the browser-based WebAssembly that's been around for a while, and all the major browsers support it. So that's well established, and if you need to run anything high performance in the browser, you should look into that, right? So that's one area that's already there. It's been around for a while. Now, the second area that's kind of established at this point is the plugins and edge use cases. So for example, Shopify has something called Shopify Functions, where you can edit the checkout experience in Shopify. And you do that by creating these functions as WebAssembly modules. And WebAssembly is a good use case for this because, first of all, it's security-wise, like, there's the code of the customer, but it's sandboxed in WebAssembly. And it's also good because the WebAssembly is really small, so you can plug it in your checkout experience. So that's one area. Also, MY proxy. It's like kind of like a load balancer, and you can write WebAssembly functions to kind of edit and customize how it does its routing. So that's kind of the edge use case. And there are others. I'm sure there are things from Fastly and others. So this area is coming up, and I would say it's kind of semi-established at this point. Another area is IoT. In IoT, you really care about the resources, so having a smaller WebAssembly module really makes sense. And finally, this new area is coming up. it's cloud microservices kind of area where, nowadays, if you want to deploy a microservice in the cloud, you either do it container-based, so you create a container and just deploy that, or you rely on a serverless kind of runtime and you define a function and deploy that and rely on the cloud provider to give you that runtime. Now, if you can take the same kind of code and make it into a WebAssembly module and run it in a smaller and faster kind of way, why not? So that's the area that's coming up now. And there are companies like I can't say it, like the Fermion, that has a framework called Spin that tries to make this easier, right? So whenever you're thinking about WebAssembly, I would think about these 4 general areas, but this is the one, the cloud microservices is the one that I'm most interested in because that's the area that I'm working on. So I'll talk more about that later. All right, so that was a really quick introduction to WebAssembly, what it is, and why we should care about it on the server side and things like that. Now let's get into details. I mentioned already that you need to have Wasm runtimes to run WebAssembly modules. I already mentioned WASI projects, so let's look into them. Well, first of all, Wasm is a portable compilation target. What this means is that you have your source code. Normally, you would compile it for some architecture, and then you would run on that architecture. Whereas in Wasm, you compile it to a Wasm module, right? So there's only one target in that sense. And then you take that Wasm module, and then you run the same module everywhere, right? So it doesn't matter if it's Linux or Darwin or whatever. As long as you have this Wasm runtime, you can take the same module that you compiled and run it on different architectures. So this is already better in terms of portability. Now, the Wasm runtimes, there are many runtimes already, and they all have their own kind of specialties. Some of them are better on the edge. Some of them are more geared towards microservices. And it's changing quite a bit. So if you go to this GitHub link, this link does a great job of listing all the runtimes and what they're good at. But from what I've seen, Wasm Time, Wasm Edge, and Wasm are kind of the top 3. I don't know if it's in terms of usage or anything like that, but at least in terms of what I've seen people use or what I've seen people talk about, these are the top 3. Wasm Time is from a Bytecode Alliance project, which is the project that's behind WASI project. Wasm Edge is from CNCF, so it's open source project on CNCF, and Wasm is from a startup that's behind WASIX that I'll talk about as well. So if you're starting up in WebAssembly on the server side, I would say go with Wasm Time or Wasm Edge and start with that because they have WASI support already. So you have your Wasm module you compiled, it's running in a Wasm runtime, and now it needs to talk to the host, right? I mean, normally this host is the browser, but now we are trying to run it outside the browser. And depending on where you're running, you need a common interface, or a system interface to talk to the host, right? Because let's imagine, for example, you want to write something to the file system. The way you write the file system on Linux is different than the way you write on Windows. So this WASI project in the middle tries to give you that system interface so that the Wasm runtimes can talk to the host. Now, WASI, it's a POSIX-inspired project, meaning it doesn't try to implement the whole POSIX. It tries to implement a subset of it that makes sense for WebAssembly. It's in preview 1, so it's not anything like production ready. And preview 2 is coming later this year. And it supports a limited number of functions. For example, it supports reading and writing files to the host. It supports program arguments, environment variables, things like that. There is some limited socket support. What that means is that there's a proposal to support sockets, but it's not implemented yet. So you cannot have sockets right now with WASI. Yeah, so these are the buts. So WASI, it's most of it is still in proposals and limited. For example, there's no socket support, so that limits what you can do with it. Some runtimes implement their own sockets to go around this. For example, Wasm Edge, the runtime has extensions for sockets, but they only work for Rust, JavaScript, and C. So you see, like, It doesn't work for every language yet. Some projects, they try to enhance WASI. For example, there's a project called WAGI. By the way, everything in WebAssembly world is like WA something. So WASI, WAGI, WASIX. So WAGI adds HTTP handlers around WASI. So the WASI doesn't support sockets, but WAGI tries to add HTTP around it, so that way they can support things like microservices. And I'll show you an example of this later. There's another project called WASIX that tries to add full POSIX support. Or that tries to add full POSIX support, but it's only supported on Wasm runtime, so it's not a standard yet. There's no garbage collection, but there's a project that tries to kind of implement that. So as you see, like WASI, it's like a good beginning, but it's a lot of proposals, and then people are kind of, I feel like people are a little bit frustrated, so they're trying to find their way around it and implement things around it so that they can support their workloads running on WebAssembly. That's the state that I think we are in right now. All right, so let me show you a quick demo now after all this talk. So what does it take to take your code and compile it to run on Wasm plus WASI? So by the way, I will refer to this as WASI from now on. So when I say WASI, I mean WebAssembly that has WASI capabilities, so it can access the host. And I have this repo that you can check for different languages. So I showed it on Rust.NET 8, Go, and Kotlin. And I will keep adding more as there's more support for languages. But let's look at Rust first, because Rust is the one that's mostly supported on WebAssembly, and see what it takes. So let me open my thing, and I have a README, so I'll just go through that quickly with you. First of all, to run this, you need to have Rust installed, and you need to have a Wasm runtime installed. So here I have Wasm time and Wasm edge installed. And if you have Wasm time installed, for example, you can do like Wasm time, and you should see that it's there. Or Wasm edge is, again, it's command line, so you can see that it's installed already. Now for Rust, all you need to do is you need to add this special target called Wasm32 WASI, which means basically I'm adding WebAssembly WASI support to my Rust toolchain. And once you do that, you create your application. And in this case, let me show you the code quickly. It's very simple. This is basically just prints hello Wasm. But after that, I want to show you that this can actually access the file system. So it can use WASI to access the file system. So here we are creating a hello world txt file on my laptop, and then I'm going to write hello world into the file as well. So I'm just printing hello world, and I'm also writing a file that says hello world as well. Something very simple, but it will prove the concept that this is WebAssembly running on my host and accessing my host using WASI. Now, once you create that, what you need to do is just build, and you pass in this target, and that specifies that this is a Wasm WASI module, basically. So let's actually build this. And let me make sure I don't have my target here. Yeah, I don't have target, so I just build that. And what this will do is that it will compile my Rust, and then it will create this target folder. And under here, you should see somewhere here, there's a Wasm Wasm file that you can run. Well, we'll run it now, so we'll see it. It's under Wasm WASI. Yeah, it's here. And under debug, and under here somewhere, there's a hello Wasm. Yeah, .wasm. So that's the module that it created for us, basically. And then to run this, you can use Wasm time or Wasm edge or whatever you have, basically in terms of runtime. But you need to specify, you need to allow your module to access your host. And to do that, it's runtime specific. So in this case, we are passing this map directory flag. And this basically says, when the module accesses hello world, map that to my current directory, right? So that's how we are allowing the module to access the directory that we want to write it to. So let me just run that quickly. So if you do that, it printed, and then it also created a hello world file, and you see that it also wrote the hello world in there, so it can access the host. So that's good. And to do the same with Wasm edge, again, it's the same kind of thing, but the flag is a little bit different. Instead of map directory, we're just saying directory. But if you run it, you will basically get the same kind of result. And just to show you that, yeah, you see it's the same thing. So I'm running the same module against different runtimes. And I could take this and run it on some other platform as well. So that's the beauty of WebAssembly, that you compile once and run it in multiple different places. So that's how it is in a nutshell. Now, At this point, you have your module and you want to probably run it somewhere like cloud or some other place. What can you do? And Docker started having support for WebAssembly. So you could technically take your WebAssembly module and wrap in a container and run it basically wherever you can run containers, right? But you might be wondering, and this is what I wondered as well. I told you the WebAssembly is the smaller, faster, more portable version of containers. So why you take that and put it in a container and run a Docker? Like, doesn't make sense, does it? And I agree, it doesn't. But at the same time, we have this ecosystem already around containers, right? We have Docker, we have Docker Hub. You can push containers, you can pull containers, you can run them on Kubernetes. So what are we going to do? We're going to throw those all away and then start a new ecosystem for WebAssembly? I don't think so. I think this ecosystem will evolve to support WebAssembly. And that's why I think Docker started supporting it. And I think that's why it kind of makes sense as an intermediary step, as we are having full WebAssembly support, maybe wrap it in a container and run it that way. So that's why it kind of doesn't make sense, but it kind of makes sense because we need to move into that future, and this is kind of the intermediary step, in my opinion. Now, how do we do this? There's another project called Run WASI, and this is a project to facilitate running Wasm managed by containerd. And starting in 4.15, Docker uses Run WASI to run Wasm with these runtimes. So it supports Wasm Edge, Wasm Time, Spin, and Slide runtime. So it doesn't support all the runtimes, just these four for now. And Azure AKS, Azure Kubernetes Service, is also previewing some Wasm node pools using Run WASI. I haven't tried it myself, but supposedly it works. So you can check that out as well. And actually, there's this blog post from Nigel Poulton that explains this quite well. So normally, you have Kubernetes and containerd managing runc that manages containers. So this is a containerized kind of world. But then in this new world, you have containerd managing containers, but it can also manage Wasm runtimes using a special WebAssembly shim, and they can run WebAssembly modules. So this is how things work currently. And then if you look at the shim, it basically has Run WASI project, and it also has the runtime within it. So, and then containerd can talk to the shim to kind of manage the WebAssembly modules. So that's the idea. And I think I have a demo running this as well. So basically, to get your WebAssembly module and run in Docker, all you need to do is, let me show you this. So hello Rust and hello Rust Docker. So all you need to do is similar to before. We created a simple app. This time I'm just saying hello Wasm before, sleep for 3 seconds, and then hello Wasm after. So that's my app. And to have it running in Docker, first of all, you need to make sure that you have Docker 4.21 or later installed. And you need to also have containerd and Wasm experimental support enabled. So if you go to Docker here and you check the settings, and then if you go to features and development, you need to make sure that this containerd is enabled and this enable Wasm is also enabled. So by having these two, now you can run WebAssembly modules in Docker. And the way it works is that, again, you build your Wasm module just like before. And then you create a Docker file where you enable these two that I talked to you about. And then you create a Docker file, and then the Docker file has this from scratch. Basically, it's not based on any other image, right? So it's based on kind of empty. And then we copy our Wasm module to the container, and then we just run that. So it's basically purely running your WebAssembly module because it's self-contained. And I guess at this point you might be wondering, is this even a container? Because it's basically empty. We just run that directly. I guess technically it is a container because you are still kind of running it under Docker with all the container C groups and all that kind of stuff. But maybe in the future it will be like running pure WebAssembly modules without any container infrastructure. I don't know. I actually had some discussions with people on this, whether this is technically a container or not. I think it is because if I run it, for example, let me go back and I think I already have it built. So let's let's make sure that I have it. Run Wasm Docker. So I can build it, and I think this should just finish quickly because I already have it built. And then when you run it, you need to define a runtime to tell Docker what Wasm runtime you want to run this on. In this case, we are running it with Wasm Edge. So if I do this, now it's running hello Wasm before in a container, and if I do the Docker PS, you can see that there's a container up and running. So in that sense, it's running in a container, but it's not based on anything, right? And then when it's finished, the container is gone as well. And then you can, after this, you can push the image, and if you go to Docker Hub, you can see that my image is here, just like in other Docker images, but it's WebAssembly, right? So that's how WebAssembly is kind of trying to integrate into existing tool chains with Docker and others. And we'll see how this evolves. Maybe in the future, there will be a pure WebAssembly module hub where you just host WebAssembly modules directly without containers in the middle. All right, I don't have that much time, so I will go a little bit quicker. So this is all cool, but right now I told you why the WASI doesn't support sockets. So that means you don't have HTTP or anything like that. So that really limits on what you can run. You cannot run microservices. But thankfully, there's a project called WAGI. It wraps HTTP around your Wasm modules. And the way it works is that first you define a modules.toml file. And in this file, you specify which path goes to which module. And then if path 1 comes along, you say, OK, this path goes to this Wasm module. And then if path 2 comes along, you say, OK, this path goes to this module. And these modules, they interface with the outside world using standard out. So they just write things out. And then WAGI converts that into HTTP responses. So if you're old enough and you remember CGIs, that's kind of the same model, but for WebAssembly. So that way, you can run Wasm modules as HTTP handlers. And actually, I will just show you quickly here how that module looks like. I won't show you the actual example because I don't have that much time. But if we look at the modules directory, you see, like I say, OK, if it's /C#, then send it to my C# compiled Wasm module. And then if it's /go, then send it to my Go compiled Wasm module, right? And then, yeah, with that, you can have your code responding to HTTP requests. And then if you look at my C# code, well, it's not this one under WAGI. If you look at my C# code, when it receives, it's just a console application, and it will just say, this is content type text plain, and then status, HTTP status 200. So it will just write that, and then WAGI will translate that into HTTP requests, responses, and then the HTTP headers, they come in as environment variables, and then the query parameters, they come as command line options, although it doesn't work for C#. I tested, it doesn't work for some reason. For Go, similar kind of thing. So if you look at my Go application, again, it's responding with just print ln statements. And then the headers, they come as environment variables. And then the query parameters, they come as command line options that you can read and respond to. OK, I have this sample on my blog. So sorry, on my repo. So feel free to check it out there with details on how to compile. But the cool thing is that one of my modules is coming from C# code. Another one is coming from Go code. They're both compiled to WebAssembly, and I can use them both from WAGI. Now, another project that's coming up that's a little bit controversial is called WASIX. And WASIX is trying to implement POSIX and extend WASI, because WASI has been around for 3-4 years, and it hasn't progressed that much. So I feel like people are getting a little bit frustrated, and then WASIX trying to say, OK, we're going to add networking, multi-threading, and all this stuff without waiting the standard to catch up, which is great. But at the same time, it only works on Wasmer runtime, and it only works with Rust, and it only works on certain versions of Linux. So it's very limited, and I couldn't get it running because I'm on Mac, right? So it's a great idea, but implementation is not there yet. All right, I won't show you this demo, but the link is here. Feel free to check it out. And lastly, I want to finish up. I will take 2 extra minutes here just to tell you the state in the frameworks and languages with WebAssembly. Well, first of all, there's a lot of frameworks out there already for WebAssembly, but one is called Spin, which is an open source framework by a company called Fermyon. And this seems to be the most comprehensive and relevant for cloud-based Wasm microservices. So if you want to play with Wasm-based microservices, take a look at Spin. It handles HTTP requests and responses using WASI that I show you. They have SDKs available, and all WASI-compatible languages are supported. So this would be a good place to take a look. And I actually have a demo in my GitHub repo that shows you how to set this up. That we'll skip. And finally, language support. One question I get from people is, what languages are supported on WASI and Wasm? And what can I do with it? That's a very complicated question to answer right now, unfortunately. And the reason for this is that, if you look at, I have these 2 resources to take a look. This is from Fermyon. This lists the languages, like, for example, Java. It says it has good browser support. It has good WASI support. C#, it has good browser support, good WASI support. So it makes you think that, okay, things are good. I can run Java and C# and all that in my WebAssembly module, right? Or if you go to this other link, this says Rust has excellent support, C++ has excellent support. So that makes you think that, okay, I can run anything I want. Well, not really. For example, first of all, you need to take WASI limitations in mind. For example, on Rust, you cannot have Tokyo or async support. This is because WASI doesn't support threads and sockets, right? So because of that, what you can do with Rust becomes very limited. Similarly, with C and C++, you don't have C++ exceptions or threads, right? So yeah, it's excellent support. If you can fall into these WASI limitations, then yeah, it has excellent support. So what excellent support means in this case is that you can use the language tools to compile your code into a WASI compatible code, but that's pretty much it. You still need to keep these WASI limitations in mind. Go, for example, has support via another project called TinyGo, but it doesn't support reflection, so you need to keep that in mind. The latest Go 1.21 release candidate has some WASI support that I need to look into. JavaScript, Shopify has something called Javi, which is a JavaScript to Wasm toolchain. So technically, you should be able to take that and compile your JavaScript application to WebAssembly. But at the same time, you can run WebAssembly JavaScript in the browser. So I don't know why you want to compile it to WebAssembly. That's another question. C# has had WASI SDK support in .NET 7, but they changed that, and now you need to have WASI experimental workload in .NET 8. They both work, so I feel like .NET people, they are trying to support WASI in their toolchain, but it keeps changing, so you need to pay attention what the status is. Java has some support by a fork of TVM. TVM, it's a virtual machine for Java to JavaScript compiler. And then Fermyon forked that into its own version, and they claim that it has Java support. I tried it, it didn't work for me, but at the same time, my Java is quite rusty nowadays, so maybe I didn't do something right. Kotlin has CoWasm, support via CoWasm, but that's Node experimental. It relies on Node experimental WASI API. So you need Node to compile Kotlin, it seems like. But I think they just announced something yesterday that I need to look into. So as you see, the language support is kind of messy. So you need to kind of check and kind of run things before you know if it's going to work or not, unfortunately. All right, so I will finish up with some conclusions, and we'll have 5 minutes for questions. So Wasm outside the browser, it's a very fast-changing landscape, as I mentioned. Standards and language support, they need to mature before you can run anything in production. Will it replace containers? Possibly. I mean, I feel like it has the potential to do so, right? Because if you can really take your code and run it in a smaller, faster, more secure way, why not? But all these standards and language support, they need to catch up before this is a reality. So I will finish by saying that I think it's an exciting time to learn this new technology. Maybe it's not ready for production yet, but I think it has the potential to be the next thing. So that's why I looked into it, and this is what I learned. So if you have any questions or comments, please let me know. And yeah, that's it. Thanks very much for listening. This is the link to my presentation. Thank you.